Hello, everyone. Thanks for inviting me to come to this awesome conference with a very beautiful country and people. So today we're gonna talk about how to develop custom application with Rust2 and Rust. I think that it's a topic that not much people is talking about, so I think it's super interesting to speak about this. Okay. So before that, I would like to know about you because I would like to know about your background, if you know about something in robotics or not, about which languages are you familiar to work with, and just to know how I should talk about. And so I'm gonna give you 1 minute, if you can. It is like a Mentimeter with some questions. Let's see which shape we get from this conference. Here you have also the okay, online people, if you want also to join. I think that's nice. I want to have the feedback just. Okay, it's a beautiful shape. Like lots of people knowing C++, Rust, and Python. Not much about robotics. It was expected, so I'm happy to see that. So my role here is gonna be to explain how robotics works and how to use these languages or just Rust now. And if you want to share about what specific topics are you hoping we'll cover in today's presentation, that would be nice also to have your feedback so I can improve from you. Yes, nice. Yes. Okay. Okay, low-level development. Okay. We can have, or maybe you can ask in the QA after if I cannot speak much. I love this page. It's beautiful. Turbines. Okay. Some Rustlet stuff. Yes, we're gonna see this. And Western robotics dancing. No, I don't have it, but we can talk about this later. How to do a mini robot. Okay, Rust and Rust. Okay, okay, it's clear, I think. Trump tariffs. Okay, come on. Okay. Let's continue. So first of all, let me introduce myself. My name is Julia Marsal. I'm a robotics software developer. I'm based in Barcelona, Spain. And I started working starting in robotics / software development 10 years ago with my bachelor's degree in industrial and technology engineering, but I didn't did anything or much about software development. It was like, so after that, I made a final thesis with the Darwin OP robot. It's a little humanoid robot that is very cute and beautiful if you want to look through this. Developing C++ applications with vision computer. Also after that, I was in a research center called EOC. Also, IRIS, another research center based on Barcelona, where I have also been there. And in the IOC, I was working with the Yumi and ABB robot, developing and integrating ROS1 to this specific robot. After that, I made a master degree in industrial engineer, specialized in automatic and control. I have a big background in automatic control, PLCs. And after everything, I realized that I wanted to be a robotics engineer. So I made a master in robotics, also in Barcelona. So when you are in academia, you didn't touch much. And I'm a person who loves learning and learning about the latest technologies. So that's why I started working with startups. Startups are really good when you love learning and you are doing the latest technologies applications and developing there. So my first company was Submer. I was developing a robotics application for data center. After that, I was in Near Space Labs. I was developing applications for a robot that flies up to the stratosphere. And last year, I moved forward and I became a robotics consultant. So parallelly, I started also to teach in EAX University, like introducing architects to robotics. That's fantastic and it's awesome. And also I'm the Rustmeet Barcelona organizer, which happens every 3 or 4 months, depending. So why I'm here and why I'm talking about Rust in robotics? Because last year I was invited in the Robotics Developers Day organized by the Construct to talk about Rust, because it was like a topic that it was new and no one wants to talk about this. So I love learning. I was there starting to talk about this topic. So I also talk in the FOSDEM conference on February, and I'm like working for the DT until now as a senior robotics engineer. So if you want to follow me, and I can share you which robotics new applications I'm developing, you can follow me here. So what we're gonna see, as you said, we're gonna see what is Rust2. Rust2, I think that's super new for you. We're gonna see why Rust and Rust for robotics, why Rust has a really big impact in the future of robotics. We're gonna see a publisher and a subscribe application. We're gonna put our hands on the code. We're gonna see how to create a publisher, a subscriber, and how to create a publisher and a subscriber node. After that, we're gonna do a step forward to make a service application using Rust. Everything is gonna be in Rust. And then we're gonna see how to create a service server, service client, and then some conclusions. Okay. So what is Rust2? I think that an image is more like 1,000 words. So let me, I don't know if I'm gonna have some, let's see.
Building robots is difficult. Motors, sensors, software, and batteries must all work together seamlessly to perform a task. But there's a way to simplify the process. The Robot Operating System, or ROS, is free and open source software that defines the components, interfaces, and tools for building advanced robots. Most robots are made up of actuators, things that move, sensors, things that read the world, and control systems, or the robot's brain. ROS helps developers quickly build these components and then easily connect them using ROS tools called topics and messages. These messages can be recorded using ROS bag files or logs for easy testing, training, and quality assurance. Messages can be easily sent to a variety of visualization and teleoperation tools. With ROS, you can work with a simulated robot instead of the real thing, which some call a digital twin. This also makes testing and training easier and more effective. ROS supports hardware interfaces for many common robot components like cameras, LiDAR, and motor controllers. ROS's modular architecture allows developers to build robots free from vendor lock-in or licensing fees. ROS can also work with just about any component. Anything that has a software interface is fair game. ROS2 supports micro-ROS, a variant of ROS that runs natively on embedded microcontrollers running real-time operating systems. ROS's framework of common tools for robot development allows you to focus on addressing your problem, not on reinventing the wheel. This is why hundreds of companies, from small startups to Fortune 500 organizations, academic research labs, and government agencies, choose ROS as their robot development platform, and have downloaded over 500 million ROS packages in 2020 alone. However, ROS is more than just software. ROS is also a community of highly trained and pragmatic roboticists applying advanced robotics to every conceivable application while sharing their solutions with each other. When you choose ROS, you're tapping into a worldwide talent pool, community resources, and an ever-growing ensemble of services built on top of ROS. These services include logging and diagnostics, fleet management, deep learning data collection, testing, and quality assurance, and a whole lot more. The ROS community is now tackling every robotics market, including agriculture, factory logistics, autonomous vehicles, service robotics, food preparation, heavy industry, drones, planetary exploration, and so much more. This community is supported by the ROS Technical Steering Committee. These organizations use ROS to build better code faster, hire talented developers, and accelerate their time to market. To learn more about ROS and how it can be used to develop your robot, visit ros.org.
So now that you are the masters of ROS, that you learn lots of things, and you're gonna know what is ROS2. ROS2 is called Robot Operating System. It's a framework that is commonly used in robotics. I think that the most used one. So it has lots of tools. One is for visualization. You can have a robot, you can have sensors, you want to visualize the data, so you have tools in the framework. Perception, to get anything sensor do you have. Robot control, you can develop, for example, control applications for your servos, and it has a ROS control layer that has been previously developed in ROS. Hardware drivers, there is different hardware drivers that has been developed, and you can download it, and different customers, different servos, there's, well, depending on the hardware that you have. AI, now AI, so there is lots of packages that has been integrated with ROS, and you can develop and start using these packages with the ROS environment that you have. Data logging, you can have logs. For example, you have a robot that fell down and you don't know why. So you can retrieve the logs and then use it and then see why the robot has fell down, or I don't know, something that you didn't expect. So you can have it. Simulation, as you have seen in the video, that you can do the digital twin. So when you want to test your code, you don't need to have the real hardware, because sometimes it's hard to have the real hardware finished. And also it's really expensive to test in real hardware, because if you, for example, you have hardware that costs a lot and you do some tests and then the hardware stops working, then maybe if you can try first in the simulation, and then when you know that works perfectly in simulation, you can work with the real robot, and then it's gonna be easier for the company and for you. And maybe sometimes your robot is, as I was working in Iceland, so it's about really far from you, so you have a simulation. It's really nice. You can test at home. Motion planning. Sometimes you want to make a motion planning to make the robot go from one point to another point. So there are tools for this. And communication. You can use different communications protocols, as it was in one of the topics, that can be integrated in ROS. So there is lots of people who are working on this specific framework, developing custom application for the different communications protocols that you would like to use. So it's really easy to integrate different parts of hardware and software in the same framework. Okay. So this is how ROS2 has been developed. Here is where normally people are in the OS layer. And there is a middleware. ROS is based on DDS. It is Data Distribution System. It's a middleware used mostly in industry. And what it has been is develop a ROS client layer on top of this. And until now, most people were using C++ and Python. But now there is the capability to work Rust. So what we're gonna see today in this talk is we're gonna develop custom application using the ROS client library written in Rust. Okay? So, why Rust and Rust2 for robotics? Why it's beautiful? It's because in Rust2, what we want is a really good performance. We want a really good safety, because we are working with robots, and sometimes you are working robots that makes surgery, so medical, or you can also work in robots that are in the aerospace or in the space. So it has to be safe. Flexibility, because we would like to be working with different threads and different processes that should occur parallelly. And the reliability, because we have to run without having any crashes. So that's it. So Rust is what it gives. It has a high performance because it's a really low-level code. Memory and type by default has been written in, it's like a safety. The concurrency, because the ownership model ensures the thread safety. You are able to run multiple threads in a concurrent way, and fewer runtime crashes, so for our system, so everyone is happy. So this is the library that we're gonna use, create, to develop custom applications for robotics. So it calls Rust2 client library for Rust. I have to, thanks to these awesome people that develops and maintains these crates. And as you can see, sometimes when you work with old libraries, it's hard to find really good documentation. And this is a really good documentation, so you can like go here and look through the methods and everything that the library itself has. And also, if you want, you can like check it here. You can develop as a crate, you can download as a crate, so no need to use any GitHub repositories, so you can install it directly. And that's it. So we're gonna see now. We're gonna see a publisher and a subscriber application. So maybe, I think that you are very familiar, but who not, we're gonna work with this. This is gonna be our friend. This is the go-to robot, okay? So we're gonna interact with this robot. So we're gonna make different applications with this robot. So we're gonna check first the publisher, then we're gonna see the subscriber, and then we're gonna see an obstacle avoidance, okay? So let's go deep. So first of all, what is a topic? This is from Rust2. It's how Rust2 works. So in Rust2, we have the topics, we have the nodes, and we have the message. So the topic, it's like the channel where I am talking. So I am talking now with you. I am talking about Rust2 Rust and robotics, for example. So you need the topic as a channel. Then you need the message. The message is what I am talking about. And then you have the node where it's going to be the application is going to be run. So the topic, or in your node, when your application, you can be a subscriber and you can be a publisher, okay? If I'm a subscriber, I am hearing of what you say. And if I am a publisher, I am publishing, I'm talking to you, okay? Maybe you know. So that's an example. For example, I have a camera. I have a camera driver, which publishes the image from the camera, okay? So the topic is gonna be, for example, camera image, okay? And the message is gonna be the image itself, okay? So then I have this node that what this node does is gets the image by this topic, and then using, for example, a YOLO algorithm, captures the boundary boxes from the people, for example. Okay? It's going to be developed in this specific node, in this specific application. Okay, so you've seen what is the topics, why we use topics, messages, why we use messages, the nodes, and how it works, the publisher and a subscriber. Okay. So in Rust, in the RCRS library, we know and we have the capability to create a subscription. So here is gonna be the type of the message that we're gonna use. Okay, this specific topic, which message is using, the topic itself, the name of the topic, the channel that we are using to intercommunicate, and the quality of service is something from DDS, and the callback, because we need a callback to get the data on every callback, okay, to get update from the data. Okay, and then we have the result. So yeah, you can see that there is specific errors defined in the crate of Rust, and okay, that is the message. So as a publisher, for example, we are gonna publish the image. So we need the type of the message of the image itself. We need the topic, the name of the topic, that should be the same if I'm talking in the same channel, and then the quality of service, okay? As a result, same. If it's okay, I'm sending out the publisher with atomic reference claim. counter, sorry, and then the error. Okay, so what is a ROS2 message? ROS2 message is the message that you are gonna like send through the topic itself. So this is two different messages that we are gonna use in this application, and you also are gonna use tomorrow in the workshop. So this is the twist message. The twist message has been designed in order to send command bells to the robot, to send velocities. Okay? So when I'm using this message, I'm just sending linear and angular velocities to the robot, and the robot should start moving. Okay? And this one has been designed to be able to work with the point cloud library. It's like just getting the 3D of each point if I have some objects around. Okay? So the most important part here is the data, that in this specific message, you have to use a mathematic algorithm to be able to decode the data to X, Y, and Z. Okay, it's different. But this is gonna come, for example, from a LiDAR, from a 3D LiDAR. Okay? So, how to create a publisher? Okay? Context is something that ROS2 needs in order to know the state of other nodes and the node itself. Okay? First, we're gonna create a node which is gonna contain our application. So this is the name of the node. Okay? And then what we're gonna do is create a publisher. What we're gonna do now is publish the velocity to the robot. I want to move the robot. So this is gonna be the name of the topic, okay? And this is gonna be the name of the message. This is where I am. I am publishing to the server that's gonna be our robot via the CMDBL topic using this message. Okay. So publisher, we are creating a publisher using the RS library. This is the name of the message, the name of the topic, and the quality of service. So I have to create a specific message which I need to fill in order to be changed depending on which velocity I want to the robot. So this is, okay, I'm gonna give an initial velocity to start working with. And meanwhile, ROS is OK, I'm gonna fill the message from the velocity, okay? This is a custom code. The idea of this code is to have the robot meanwhile moving under control. And I'm doing the algorithm of the mathematical algorithm that I am using for the robot is a pendulum movement. That's why I am increasing and decreasing the velocity just to make a velocity movement pendulum, okay? So yeah, just depending on the velocity, I'm changing it on every loop, and then I am increasing and decreasing depending on where we are. And then I'm moving, I'm printing, okay, I'm moving linear and angular with this velocity, and then I am publishing, I am sending to the robot this specific message. Okay, and then I'm putting the 3 to sleep a little. Okay. So this is our friend that starts to move. So I'm able to interact with the robot and sending and publishing a velocity. Okay. Then I know how to interact, how to talk with, but how I can hear from the robot. To create a subscriber to hear from the robot, I need more or less the same as before. Need the context, like to know how the state of the other nodes are, and the node itself. I need to pass through the context, and this is gonna be our new node, our new application. Okay, this is the scam subscriber. That's the name of the node, and then I'm creating a subscription. Okay, so the subscription is gonna be the type of the message is gonna be a point cloud 2 because I want to get data from the scan from the LiDAR for the robot, and then this is gonna be the name of the topic. Okay, so what I am doing. The server is the robot, so I am getting information through the Velodyne points topic, And the type of the message is a point cloud 2. Okay? So this is what I'm doing here. So this is on every callback. Okay? This is a subscription. So on every callback that I am getting from the robot, what I'm doing is using a specific algorithm to be able to decode the data from the message itself. I am extracting the X and Y from the data that I'm getting from the point cloud. And then, depending on which distance I have, this is a specific application. Maybe I can print that I have detected an obstacle to the left in a specific distance. Okay, so for example, I could move around depending on if I have an object around. Okay, so you can see that there is going to be different ifs here. This is if I detect something in the left because it's the Y, but maybe I also can do this for the front to the X. If I detect something in the front in the X, for example, move backwards, or I can do also the same if I can detect something in the backwards. So you can play and make the robot move depending of if you have some objects around. Okay, you need to spin the node in this case to make the callback being called. Okay, if not, you cannot get the callbacks from the robot. Okay, so that's it. This is our friend. This is stop now. So I am moving around a box, and the robot knows, you can see here, that you are placing an object in the different positions of the robot. So you know how to develop an application depending on you have an object moving around. So now we have how to hear, we have how to talk, but let's put it together. Okay, it's a bit trickier because now we have to interact and to talk with different topics, different messages, and you have to develop custom applications regarding this. So this is our new application. Okay, same server, and now we're gonna have only one node with the both topics. And we're going to talk with the CMDevel topic to get the velocity, or to send the velocity. And then we're going to get the scan from the LiDAR through the point cloud 2 Velodyne's topic. So here is the twist message, same as before. We're going to use in order to fill and send the velocity to the robot. And then I need to make a clone because kind of things of Rust that we need to do. And we're going to create a publisher that what they're going to do is to publish the velocity to the robot. So here I am creating the subscription. Okay. In this case, I'm implementing a struct that I'm going to use after just to be able to change the velocity. Meanwhile, I am having a callback from the scan of the robot. So yeah, let's create a publisher just to publish the velocity, the subscription to make the callback of the robot to get the scan from the robot. And then on each callback that I have from the scan, I need to change the message from the robot and to fill accordingly if I want to move depending on what I get from the scan of the robot. Okay, so in this case, it's like some example. If I have some obstacle in the left, okay, and then, for example, this is to detect that I have something in the Y, and this is to detect if there is a specific angle. Then what I'm doing is filling and changing the angular velocity of the robot to move accordingly and to avoid the object. Okay, so this is the main function, same as before, context, the node itself, we're creating a node, this is another name, different name, and then we are creating or using the struct just to be able to use it in the loop, in the main loop. So here I'm I'm publishing, but this publishing, that is a function that is not defined here, what it's gonna do only is gonna publish the twist message clone on every loop. Okay, but who's gonna fill the message to be able to change the velocity depending on the scan of the robot is gonna be the callback itself. Okay, then I spin once, and then I put the node to sleep. Okay. So this is like an application that the robot is gonna move around, and it's gonna start avoiding the objects. In robotics, we have other ways to do this. There is like a specific like application or package that is called the SLAM that uses lots and lots of data and lots of sensors. That is like a basic application that you can do just to understand how to work with this. So you've seen how to interact with topics. Okay, topics is like something that you can use in a long-term kind of actions. But sometimes it's interesting to have services. Okay, we also have services in robotics. We use it. So, for example, as it is explained in this example, for example, you can have a robotics arm, and you want to close the gripper because you want to make a pick. Okay, you can have different kind of grippers. There are grippers that has more intelligence and more sensors, but there are ones that you can only close and open the gripper. Okay, every hardware has its own like software specifications, so sometimes you have to be clever and develop custom things. If you don't have the hardware, cannot bring it to you. So this service, so we want to close the gripper. Okay, so I have the service, and I'm gonna have a request that it's gonna be close the gripper, and then I'm gonna send a feedback, and depending on the sensor, maybe I have a force, like a torque feedback or intensity feedback that I can say, okay, I have closed, or whatever you want. So the response itself. So you have the service server that is gonna wait until the client makes a request, and it's gonna close when it's gonna be requested. So same services, then messages. Services has its own messages. Okay, they are a bit different as we have seen before because it has its own request and reply message. Okay, you have to define both. Okay, so there are messages, but they are not in the same folder as the common messages. It's in the service messages. Also, you can use, if you want messages from common messages, here in the services message, but up to you. Also nodes, same, we're gonna have our applications, and then the client server application. Okay, so let's see how to create a service server. So same, you need to pass through the type of the message, and then the callback function. Okay, we're gonna be like executing, just waiting for a request from the client. Okay, so this is an ID from the from ROS, and this is gonna be our request. Okay, that we're gonna receive, and then the response that we're gonna give, and then service client. This is the create client. We want to create a client. We need to pass through the type of the message, and then this is the topic. Okay, that you want to talk. It's like more or less as we just seen in the topics, but in services you have also a services topics, more or less. Okay, yeah, that's it. So what we're gonna do now is to create an application that the client is gonna send a command to the server using a custom command service message. Okay, this is the custom message from the that we have like previously defined. This is gonna be the request, a command, just sending a command that is inserted to, And this is the response that we're gonna get from the when it's closed. Okay? So if we send 0 through this service topic, the robot should stop. And if we send a 1, the robot should move. Okay? So this is how to create the server itself. We just gonna wait until the client sends us some command using this specific message. So this is the main code, same as before, context, the node itself that's gonna contain the server. And this is the publisher that we are gonna publish when it's gonna be closed. Okay? So as we are interacting with the robot and we want to stop the robot, we need to publish to the twist message for the robot, to the CMDevel topic, to be able to stop the robot when we are gonna request it. So this is gonna be our server. We're gonna create a service, and this is gonna be our custom message from this specific service topic. So we're gonna use specifically these both like variables. We're gonna use it here in this specific callback function. And yeah, just here we're gonna use this publisher, the request that they're gonna receive from the services. And this is what, if you want to, you can print it, but it's just the ID of the service. So that's it. Using this, and then we're gonna get a response. Okay. So here we are doing is like defining a row, like a default message for the twist message that is gonna be all zeros. Okay. And then we're gonna, depending on what we receive from the request from the client, we're gonna do different things. If I receive a stop, then I'm gonna publish a command to stop to the robot. It's just using the same twist message that this is here. Or if it's start, I'm gonna like change this message in order to, for example, start moving the robot. Okay. Yeah, here, and then we're gonna spin it because we have a callback. And then now we have the server. We are waiting until the client says something. So we're gonna make the client in order to make the robot move around. So same as before, context, the node that's gonna contain the application, and now we are defining the client. Okay, creating the client, and then there's gonna be our custom message and the name of the service topic that we are gonna use in order to send like a request to the client to stop the robot or to start the robot. There's gonna be our request. There's gonna be, in this case, a start. Okay. So meanwhile, the client, so it's not ready. The server then sleep the thread, and if the server then it's ready, so then send a request with callback. Okay. You can create, if you want, here functions, but in this case, the callback is gonna be here. And then, yeah, we are passing through the request here, and then, yeah, we are sending through this specific service topic. We are sending through this specific command response type, and we are printing, okay, what we have received from the server. Okay, we're gonna put the thread to sleep, and then we are spinning because we could have some callbacks. And that's it. Before, when it started, we have sent a start. The client has sent a start, and now it has sent a stop. Okay. So as a conclusions from the meeting, or the talk, I have to say that Rust, what it has is a memory and thread safety. By default, it's a language that has been developed thinking about these things. It's a high-level code without performance overhead, which is really good because you can have safety and efficiency at the same time. it has its own way to handle the robust error handling, and it has an excellent performance by default. But as far as I have seen, the learning curve for people who don't know how to work with software development, maybe at the beginning it's hard, and also some people in robotics that could come from languages that are not using kind of or know how to handle memory, that could be hard. But I have to say that, well, if you want to, you can do it. Ecosystem immaturity, there is no much people and also libraries that you can use in order to use like Rust now. But, and also the legacy integration, because maybe you have legacy code that you want to integrate and maybe it's kind of difficult to be integrated. And the compile time, because in compile time it's where most of like Rust things happen. So that's why it can be, when you compile from scratch, maybe it's gonna take you longer. So I would like to thank you for coming, for your patience. And if you want to, tomorrow we're gonna do the Rust workshop. We're gonna do the same as you've seen today. You're gonna see our friend moving. If you want to download it today, that would be nice, because maybe it's gonna take time to compile everything and to download the Docker images and dev containers. And if you have anything or want to talk or discuss, reach me out here. So thank you.
Okay, and we have some questions, 8 questions. So the first one is, where can you see possible interaction of ROS with Ratatouille?
Okay, we can talk about it later with... I think that's nice to talk about it later with Arun.
Okay.
Okay, but good question. Thank you.
Next, did you know when we can expect actions in Rust RCL implementation?
I think that they are done, but I'm not pretty sure. But it's gonna be there. I don't know when, but I think it's there. So I'm not sure, but I would say it really soon.
Next one is Rust in ROS2 ready for a production use?
It's a really, really good question. I have to say that Rust, it's not, when you download the code and you want to just make like a downloading from scratch using binaries, it's not integrated in ROS2 now. But I have to say that production use, I wouldn't say, but I would say that it's, if you want to start using it, just to help to the community to improve and be robust as soon as possible, I think would be nice. But the production use, the thing is that it still hasn't been integrated with like the ROS2 binaries. So I would say that I would use, if you want to start using or creating a project from scratch, I would like to recommend you to use it. But as a production use, I wouldn't say.
Okay, let's go to the next question. The next question is, what can we do as the community to make Rust more popular in robotics?
Wow, good question. I have to say that develop custom applications. It's like, if you have some ideas about where you can use Rust and ROS2, just do it. So don't think about this. And if you have some question, you can also ask to the community. There is a really good community in ROS2, and people are really kind, and you can ask there, and someone will ask you for sure. But just making new applications with Rust. That's it. Have some really good ideas and do it. Don't think much about this. Yeah.
Okay, the next question is from Arto. Do the ergonomics, lifetimes memory stuff get annoying when writing ROS code? How do you get around those?
Yeah, that's a really good thing. From my experience, that I'm I come from C++. I would say that when I have to say that when you the compiler itself is a really good because sometimes it shows you how to fix some issues, but you have also to learn about Rust, how lifetime goes, and after that, with the compiler itself, and maybe a good or a bit help from kind of AI or copilots, I think that is how I mostly go through this specific ergonomics. So yeah, that's what I'm doing, but maybe someone doing different things that I would like to know. So yeah, that's it.
Next question. What is typical hardware, CPU architecture specs? How are the components physically interconnected? Serial interface or RJ45?
Okay. Yeah. So normally what we do in robotics, we have like a computer, so you can have different peripherals connect to that computer. And yeah, this is the main computer that's gonna use the CPU itself. So if you want to interconnect, also you can develop your custom PCBs if you want, you can use it, and you could have, so for example, more embedded side, you could have some UARTs, E2C protocols if you want to use it, no problem, depending on what do you want. If low level, you can use, for example, the SP2 that we have here. You can use the micro ROS, so you can connect input output. You can use what you have here in this device. Or if you want thinking about more in industrial, you could use like mostly what we use is like a main computer. So we have an industrial computer, and then we have PLCs in industrial. So you can have a PLC with different inputs, outputs, and use these signals. And also, if you would like to have more like open source, you could have your own computer and connect cameras and everything to what you have. It's depending on your architecture at least. So yeah, you can use RG45. You can use, if you want, there is Modbus applications. I don't know. There's lots of packages that you can use that it has been wrapped in ROS2 that you can use in your applications. So that's it.
Okay, interesting question. How much do you think AI will affect the robotics work? Do you think manually coding reaction algorithm will be obsolete?
It's a really good question. I have to say that robotics work will change, but it will change in mostly people's work. But for me, it's a good thing because I have to say that I love to be everywhere, and sometimes if you love to be in the last technologies and you want to do the best code ever that you could do, you need a lot of time to go deeply in the code and have the beautiful code that you can like bring. So AI for me has helped me a lot just to document it better. And for example, if you want to read some readmes, you can ask to please, can you help me to write a README? And I think that's beautiful to have this kind of help. Also, if you want to document a SDK or a docstring, you can use AI to help you. Maybe it's not the best, but sometimes it's gonna make your like the basic, and then you can improve it. So it's gonna change. I think that it's gonna help you, and we need to understand how to use these tools because it can make our lives easier, but always with an eye on it, because AI, you don't know, you have to sometimes give really good context about what you want. So you have to, I think that you have to become friend of AI to know each other, how to work together. But it has a really big future in robotics, and it's a present, so it's not a future. So yeah, we have to start working with this. Yeah.
Okay, next one. What we can do with the thin bandwidth on service bus in ROS? Example, video data on one bus and simple data on other data bus. Do we need to use quality of service or other solutions to improve performance?
I have to say that I'm not much familiar with this, but yeah, I would say that depending on your application. So there is nowadays in ROS2 there is different ways to that have like solve this kind of issues, I think, that you can use, but I'm not quite familiar with this, so I'm sorry, but yeah, that's it.
If I wanted to program a real robot, what's a good and cheap model to get started with ROS?
Wow, that's a really good question. I would say simulation. Now, I think that thanks for AI or not, I don't know, there's really good simulations or simulators that you can use. So what I would say is go through like a robot that has been really good simulated and really good documented. I will start with the robot. And then I would say, okay, start working with the topics that the robot gives you. And if not, you can implement your own custom topics and services. So you can do your own software. And if you want to go through like a hardware or real robot, there is really good open sources projects that you can develop and download from, for example, a robotics arm that you can print with a 3D printer, and then you can buy some servos that are kind of cheap of servos. Also, you don't need, if you want to use ROS, it has its own Python and C++ SDK, so you don't need ROS. But I would say that open source hardware, there is lots of projects that you can look through this and start working if you want. And regarding simulations, I would say that there are lots of simulation examples that you can download and start working with. So I like ROS because I think that ROS gives you the overall view on the overall application. You can work with computer vision. You can work with different applications with the same language that is going to be ROS, but you don't need to use ROS if you need it. So depending on your application.
How do you handle time constraints, ROS?
I don't understand this question.
Maybe someone who wrote it is here in the room and can precise it. Yeah, so maybe.
No problem.
Wait a moment. If you don't have a mic, you don't have a voice.
That's it.
Yeah, so my question, I think you partially answered, like you mentioned the quality of service, for example, but my question is like, because it's not a real-time operating systems, yeah? So how would you use ROS in situations when you actually need solve this time constraints, that you have to be sure that something is executed in some really precise time?
Yes, now it's a really good question. There is like a kind of real-time, there's lots of people who is talking about this topic. It calls real-time performance. And it's a really good topic because in aerospace and also in medical like environments, do you exactly need this? So what people does, some of the people, I think that goes to ROS and makes different changes to be able to work as you want to work. Also, there is new improvements in ROS2 that I'm not really familiar, that has think about this and has improved it. But how ROS2, as far as I know, it works about the priority. So the first like topic that you've like implement is, I think that's gonna be high priority. So yeah, I would say there is a lot of people who are working on this. I cannot give the answer, but there is, you can find it in if you search it, you can find it because there is lots of people who is aware of this. And now ROS has been but is using also in NASA. There is like they are working also with kind of ROS. So it is a common topic. So yeah, just search for it. So feel sorry.
Okay, thank you for answer. What do you think about Atos Tech's native Rust DDS implementation and native ROS2 client library based on it? It has actions.
Yes, good question. I would say that maybe it's gonna. I would say that ROS2 client library, as far as it has been developed, it has think more in how ROS2 architecture, as like you go to the RCL written in Python, and you go to the C++ one, and you will find the same methods. So maybe this one, the Rust-DDS that I'm not familiar, doesn't work in the same way with the same methods that has been designed in the other client libraries. So that's what I would say.
Okay, now question, do you have a real go-to robot with you?
Yes, I wanted to bring, but the thing is that I didn't have time to bring it. But yeah, I have one, and some spoilers, I'm gonna release some Rust application in the future with the go-to. So yeah, this is beautiful robot. You have to see it. Yeah.
And the last question is from Rafał. Can you deploy machine learning models using ROS2, for example, to activate based on data received from specific sensors on the robot?
Yes, there are lots of packages and libraries that does this. I'm not familiar, but yes, you can do it. Lots of people are using YOLO. I've also, personally, I've been developed and trained kind of model in YOLO a few times ago. So you can do it. You can deploy it. You can use, for example, you can develop your custom applications that contains machine models and also have a really good computer with a really good GPU, run it. And also another thing, a good thing about Rust2 is that you can share the topics between different computers with the network itself. You can change it. So you can work in your own computer, and then in another computer you can access to your topics. So yeah, you can do it. You have different ways to do this. So that's it.